All right, so in this video, we're going to talk about a binomial distribution. So this corresponds with Unit 3, Homework 2. All right, so here we go. We're on a game show. We have a contestant that spins a wheel divided into 36 pieces. We have 2 golden wedges, and they're worth $50,000, so no other spots win. Okay, so I'm asking, what is the probability of winning? All right, and so that's 2 spots out of 36, which is like 1 out of 18. So that's fine. Then we have the probability of not winning. So that would be every other spot. So that's the 34 out of 36, or that would be 17 out of 18. Okay, so this scenario right here is called a binomial distribution. So that means there's only 2 possible outcomes. We can either win or lose. So we typically refer to these outcomes as success and failure. All right, the probability of getting a success, we're going to call that a P, and the probability of failure is called a Q. All right, now one property that these 2 things have is that we can add them together and they should equal 1. Okay, that also means that the probability of Q will equal 1 minus P. Okay. All right, so we have some new formulas since we're dealing with a different type of material. The mean is going to be N times P. All right, and the standard deviation is N times P times Q. Okay, so there's some new formulas for you. All right, we're going to learn this formula for finding the probability of this binomial distribution where we have either 2 outcomes, success or failure. All right, and so it looks like this. The probability of X equaling something is, this is called N combination X, and that's going to get multiplied by P to the X power and Q to the N minus X power. And I know that looks a little crazy, so we're going to talk about it. This right here, this N represents the total number of trials, and X is the amount we're looking for. All right, P is our probability of success, and Q is the probability of failure. Okay. All right, this NCX, this is new. Okay, so let's talk about that. All right, this means we're going to do N factorial divided by X factorial times N minus X factorial. Okay, this exclamation point is called a factorial. And what that means is if I have 5 factorial, that means I want to figure out 5 times 4 times 3 times 2 times 1. Okay, and so whatever that is, 120 would be what 5 factorial means. Okay, 13 factorial would be like 13 times 12 times 11 times all the way down till you get to 1. Okay, and 13 factorial is a really big number. Okay, as you can imagine, these get big pretty fast. All right, let's see, 6 billion something. Okay. All right. Okay, so on your calculators, okay, there is a button that says PRB. Okay, so if you press that and then scroll to the right, you should be able to see an exclamation point. So you can use your calculator to help you that. So I could type 6 and then that PRB button, scroll to the right, hit that factorial, and then enter. And on my calculator, it should look like 6 factorial. I can hit equals again and get something like 720. Okay, so if you have a question on how to use your calculator, send me the type of calculator you have and we can certainly work that out. Okay. All right, so really for this formula, instead of this written right here, I can do n factorial over x factorial n minus x factorial. Then that's going to be multiplied by p to the x, and that's going to be multiplied by q to the n minus x. Okay. All right, so let's take a look at what in the world that actually means. Okay. Okay. So we have 6-question multiple choice quiz where each question has 4 choices. What is the probability of getting a single question right? Okay, so if a question has 4 choices, then the probability that we get one right would be 1 out of 4 or 0.25, okay? What's the probability that we got one wrong? So the probability that we got one wrong would be like 3/4, and that is 0.75, okay? All right, so I want to know, what is the probability of getting exactly 4 questions right? Okay, well here at the top it tells me there's only 6 questions total on this quiz. So n equals 6, and x equals 4. Okay, I'm looking for getting questions right. So for this example, that's telling me my probability of success is 0.25 and my probability of failure is 0.75. Okay, so now I'm going to use this formula. So it's going to look like n factorial, so that's 6 factorial divided by x factorial, which is 4, times n minus x, so 6 minus 4 is 2. That's going to get multiplied by p to the power of x, and that will get multiplied by q to the power of n minus x, so that's a 2. Okay. All right, now in my calculator, I'm going to do this right here first. So in my calculator, I'm going to do parentheses 6 factorial. Actually, scrap that. I'm going to do 6 factorial divided by parentheses 4 factorial, 2 factorial, and I'm going to put those parentheses around that denominator. Okay, and let's see what we get here. All right, I got 15. Okay, so this is going to look like 15 times 0.25 to the 4th times 0.75 to the 2nd. Now I'm going to do all of that in my calculator in one step. Okay, so I'm going to do 15 times 0.25 to the 4th, and then 0.75 to the 2nd, and I have 0. Hold on. Let me do that again. 15 times 0.25 to the 4th times 0.75 to the 2nd. Okay, yep, that's right. I got 0.0329, so I'm going to round that to 0.0330 if I needed to round to 4 decimal places, okay, because there's a 5 here. All right, for the next question, it says, what is the probability of getting less than 2 questions wrong? So now it looks like x is less than 2. So that really means 2 things. That means x can equal 1 and x can equal 0. So I'm going to have to do that formula 2 times. All right, so it's going to look like 6 factorial over 1 factorial and then 6 minus 1 factorial times, 2 questions wrong. So now, see how this wording changes? We're looking at something that's wrong. So the probability of getting something wrong is 0.75. The probability of getting something right is 0.25. So my success and failure has changed for this question. All right, so now I'm going to say 0.75 to the first and 0.25 to the fifth. Okay. All right. So I'm going to do this part in my calculator first. So 6 factorial divided by 1 factorial, 5 factorial. That should just equal 6. Yeah. All right, so now this becomes 6 times 0.75. If your exponent is 1, we don't actually need to type that in. That's just the first power. And then 0.25 to the fifth. So when I type all of that in my calculator, I should get 0.000244. No. Excuse me. That's for the next problem. 0.004395. All right, so for x equals 0, now we have 6 factorial over 0 factorial, 6 minus 0 factorial, 0.75 to the 0, and 0.25 to the 6. Okay, 0 factorial equals 1. So this is going to become 6 factorial over 6 factorial, which is 1, times 0.75 to the power of 0. That is also actually 1. And then 0.25 to the 6th power. So when I do all this, I get 0.000244. I've got to add these two things together to find that final answer. So when I do, I'll have 0.0046 for my final answer for this question. All right, so now we have this table up here. Okay, if you're given a problem and the probability in the problem is one of these listed, okay, can y'all see that? If this is your P for one of these problems, we can use this big table instead of that formula. So we can use the table instead of the formula. All right, the table can be found in Moodle. All right, I've got one there for you. You can also Google a table if you would prefer a different one, but the one in Moodle is the one I use, and it seems to be pretty good. Okay, so we're going to use this table to answer the rest of the questions about the binomial probability. Okay. All right, so here we go. We have Thad making a free throw in the championship basketball game. That probability is 60%. So there's my p-value. That's our success in this situation. Okay. Assume Thad attempts 7 free throws. So there's your n. What is the probability that he will make 4 free throws? So now x is 4. All right, so here's what we need to do. We need to find our table. Where n is 7. So n is 7. Here's the n's. And my probability is 0.6. So I'm looking down this column. Okay. Now, the question says we want to know the probability of him making exactly 4 free throws. So here's my x's right here. So I found where x is 4. And I'm going to go across. And that 0.2903, that is my answer. That's my probability. All right, so I can say my answer is 0.2903. Okay. All right, the probability that he will make more than 4 of his free throws. So now that's the probability of x is greater than 4. So that's x equals 5, 6, and 7. All right, so we're going to go to that table. All right, and now we're looking for when x is 5, 6, and 7. All right, so these 3 numbers right here, I've got to add those together to get my answer that I need. All right, so for 5, we have 0.2613, then 0.1306, then 0.0280. We're going to add those things together. So my final answer is 0.4199 for this question. Okay. The probability he will make no more than 2 free throws, so that's the probability that x is less than 2. So I would do x equals 1 and x equals 0. I would use that table to find those probabilities in that same area. Just when x is 1 and x is 2, I would add these together and I get 0.018 for my answer. Okay. All right, for this next question, it says freshmen account for 30% of the student body, so that's your P. All right, if a group of 12 students is randomly chosen to comment on textbook prices, what is the probability that fewer than 3 of these students are freshmen? So we're going to say x is less than 3. So that means 2, 1, whoops, and 0. All right, so we are going to our table, and we need n is 12. So now I need to find 12. Here we go. All right, so this time, n is 12. I need to do, let's see, x is 0, 1, and 2. So here's my x's. Here's 0, 1, and 2. So I'm looking right here. Probability is 0.3. So I need to add up those 3 numbers to answer this question. All right. So we have a final answer of 0.2528 when I add up those 3 numbers. Okay. All right, for this one, it changes, the n changes. Now we're at n equals 10. All right, our probability is still 0.30. Now it says that more than 3, so you can write that like x is greater than or equal to 4, or you could say x is greater than 3. Either way, you need to do 4, 5, 6, 7, 8, 9, and 10. Find the probabilities for all of those and add them up in that table. Okay, and I got a final answer of 0.3503. Okay. All right. If a group of 40 students is chosen, how many would you expect to be freshmen? So this is actually not a probability question. We know 30% of the students are freshmen, so I'd say 0.30 times 40, and we would get 12 here. Okay. All right, last example here. All right. Flights are on time 80% of the time, so that's our p-value. We have 8 flights, so n equals 8. Find the probability that exactly 3 flights are on time, so x is 3. Okay, so we're going to our table. I need to find n equals 8. All right. Let's see, the probability here is 3 for x and 80, so looks like 0.0092 is our answer for that one. All right, and then for our last one, the probability that at least 3 flights are on time. So we can include the 3 there. So we would need 3, 4, 5, 6, 7, and 8. I would need to find the probabilities for all of those and add it together. My final answer was 0.9988 using that table.